Naomi and Joe, if you guys want to get to the quiz, we'll just jump right in.
Alright. How are you going to start?
No, that's what
I'm opening right now.
Gonna do right now. We're just gonna jump right in and do the quiz.
Okay.
Okay.
Are there more questions here?
Hey, Dylan.
What's up?
So I can't really hear Naomi and Joe too well, so if we need to, we might have to have, because I don't have the problems in front of me, we may need to have you read them so that I can do my best to help answer and stuff.
Okay, well, let me see if I can set my phone anywhere better so that you'd be able to hear them.
Okay.
If not, I can do all the reading. I've got no problem with that.
Okay, cool.
Okay, so I guess we'll just start in with number 3. So, which of the following variables is or are categorical? There are 4 options: the number of animals in a local zoo, a randomly selected brand of toothpaste at a convenience store, age and years of a randomly selected vehicle in a parking lot, or A and B. From what I remember, the only one that would be categorical there is B.
Yeah.
Yeah, the toothpaste one?
Yeah.
Yeah, I agree.
Because the rest of it is all numbers.
The other two was number of animals, and what was the third one?
Age and years of randomly selected vehicles in a parking lot.
Yeah.
Yep. I agree with that.
Okay, so let's try Naomi or Joe. If you guys want to read off number 4, I'll put my speaker up to the mic for my phone so that Tyler can hopefully hear it.
Okay, I'll read it.
I'll read number 4. Okay, go ahead, Joe. That's fine.
Can you hear that, Tyler?
It's pretty choppy. I wasn't able to make anything of it.
Okay. Go ahead and read it, Joe, and if I need to reread it, I will for Tyler.
Okay. The mean IQ test in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is true? 100 is a parameter. 112 is a parameter. 100 is a statistic. 112 is a statistic. I'm thinking 100 and 112 are both statistics.
Could you hear that, Tyler?
No, not too good.
Okay, so let me reread this for you really quick. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is or are true? And the options are 100 is a parameter, 112 is a parameter, 100 is a statistic, and 112 is a statistic. And Joe thinks that 100 and 112 are both statistics, which I would agree with.
Yeah. What's a parameter again? I know it's something to gauge off of the...
A parameter is like a limitation.
A limitation.
Yeah, when we talk about parameters, we're talking about, like, you know, the idea that in our probabilities, it has to be greater than 0 and less than 1.
Right.
That would be a parameter of types.
Okay.
So where the mean IQ test score across the United States is 100, and then the mean of all of these students is 112, those are both statistics.
That makes sense. That makes sense.
Okay, so I guess since Tyler can't hear these, I'll just keep reading through. And then we can just rotate, I guess, with who answers what. So Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to proposed increase in property tax? And then the options are a simple random sample, a systematic sample, a cluster sample, or a stratified sample.
I initially thought stratified.
Well, is stratified? Is stratified the one that we would take a sample from each of the individual groups? So we've got.
A sample of a simple random inside each.
Well, the simple random would just kind of be saying, okay, cool, we're gonna start at the 5th house, and every 10th house after that, we take a sample from.
Right. With the strata, it's like you take a simple random sample of each. It would be a simple random sample of each neighborhood broken up into different groups, right?
That's what I remember. Or it would be like a systematic sampling inside of each neighborhood.
I have stratified samples. I think I can read you all the definition of a stratified sample real quick.
Okay.
So we can find it here. Okay, stratified divides into similar groups, and a simple random sample is taken from each group.
Okay, so yeah, it would probably be stratified. What do you think, Naomi?
Yeah.
Yeah. Yeah, stratified sounds right.
Okay.
Mm-hmm.
Yeah,
I would agree with that.
Okay. And there are 35 questions on this. This is a lot. Tyler, how long do you have?
I have probably about 5 or 10 more minutes.
Okay. So let's go ahead and cruise.
So, it's alright though. I'll be okay.
Okay. And I can send you the link to the YouTube video so you can watch the rest of what we do as well.
Oh, yeah, that is solid. That's a good idea.
Okay, cool. So number 6. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected class. Which size of sampling scheme, or which type of sampling scheme is implemented?
Oh.
And it's simple random, voluntary response, systematic, stratified, or cluster sample are the options.
I put cluster.
I was thinking cluster because it's not spread out through any groups. It's very narrow, and then they take from all of those students.
Mm-hmm.
Yeah, that's the big evidence.
Yep.
Either a sample from everyone in each group.
Right. And they only take it from one group instead of going to, each group, or 3 or 4 different groups.
Simple random.
Yeah. Okay. Perfect. So these first couple are all just like this.
Oh, nice.
So number 7, at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Simple random, a voluntary response, systematic, stratified, or cluster? I would think simple random.
Simple, yeah, it's a simple random.
That's what I said.
It's kind of thrown into a hat and pulled out.
Yeah.
Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Mm.
Would that be stratified?
Yeah, because it's not systematic.
No, it's not simple random. I'm wondering if it's the voluntary response.
Did we learn about that?
Is that one of the options?
Yeah. I don't remember learning about that.
Voluntary response.
One more time.
One second. Hey, Joe, can you repeat what you just said?
I said I don't think we covered a voluntary response at all.
Yeah.
I don't think so either.
Good luck.
It's
For the main part of this, no. Sorry, Joe. What?
I said I'm pretty sure it's stratified.
You're thinking stratified?
Yes.
That's what I was thinking.
Okay. I think that's probably our best bet then.
Hey, you know what? I think I'm gonna have to jump off now.
Okay. No worries. Thanks for calling in and being with us for part of this, Tyler.
No problem. Hey, thank you. We'll see you guys later.
Awesome. See ya.
Bye. Good luck.
Okay, does somebody want to take question 9?
I didn't do the network thing because I was having trouble like accessing everything, so I don't actually have the information to do that.
Okay.
Then.
Okay, I need to open that data file.
Which data file is it?
Crossroads?
Okay. Take a second first. No. Oh, come on. At one point in time, I had found these for Excel.
Yeah.
Oh shoot! You know, I just barely realized. I think you have to open it up in that thing. Like I can't open it up on the desktop that I'm in right now. I have to go into the into like that laptop desktop thing.
SPSS?
Yeah.
If you go from like the textbook, do you see that search bar there?
Yeah.
And you type in data /Excel, it'll bring up versions of all the data spreadsheets that are in Excel format, so that you can look at them without having to use the SPSS. Because I have a hard time using the SPSS. My computer really doesn't like it.
Okay, so it says a survey was taken of the purchase of the Crossroads. Open the data file, Crossroads purchases. So I just click on that, right?
Yeah.
And then what's the next thing I
Find the
do?
Excel data file.
Find the accompanying file, yeah. And so let's see. Crossroad purchases. Okay, so I click on that, and it doesn't allow me to bring it up.
What does it do?
It says, how do you want to open this file? And it says, look for an app in the App Store, Internet Explorer, Microsoft, Movie Maker, Notepad, Paint, Photo. It has a list of things I can open it up in. And I've like already tried one of these, and it gave me like a bunch of it gave me like 5 pages of coding.
Right. So you're trying to look at those using SPSS, and you don't have it. In the search bar, you see the search bar right at the top of the screen for the textbook page that the data is on?
Just 1 second. Alright, so just open Let's see. Okay, so the search bar. I go to the search bar, and it says statistics.boimath.com/index php # title equals data. So what do I do there?
I'm sorry, what?
You guys still there?
Yeah.
So I go to the search bar and I type in what?
Type in data \Excel.
So even
EXCEL.
after it says data?
And it should bring it up so that you can look at it in an Excel worksheet.
I have no idea what you're talking about, my friend. So this, like the search bar where I type in the website, right?
No, there's a search bar underneath that's actually part of the page for your textbook.
Oh, data/Excel. Okay.
Yeah, and then you can type in data \Excel there, and it should bring it up.
Oh, okay. Sounds good.
Okay.
All right. So once we get there, now the questions are what?
So the first question is, using software, calculate the mean of these data. And I got, rounding to 3 decimal places, I got 4.771 as the mean.
All right.
How do you work Excel?
So,
How do you find the
Okay.
data?
Do you have all your values sitting in front of you?
Yeah.
Okay. Take your little mouse thing and click on the top value and drag it all the way down to the bottom.
So we're doing the
The
amount,
very
right?
last number. What was that?
We're doing the amount.
the mean.
Yeah, your amount, so like your numbers. So my first number is 2.3, or 2.23. I'm going to click on that cell, and I'm
Okay.
just going to hold my mouse down, and I'm just going to drag it all the way down to the very last number, which is 2.2.
Okay.
Alright, so, well, actually, there's one thing before that, sorry. That's how you select everything. I've got to enable editing here. So first thing you do, you click on any random cell and you press your equal sign, and then you type in mean. Sorry.
So are you in Excel right now, Naomi?
Yeah. I have it highlighted, and then I push the equal sign after I highlight it.
The easiest thing to do, go click out in a separate square. It can be anywhere.
Okay.
Okay, so Excel is programmed to be actually very user-friendly. So you know that little bar across the top that you can type in?
Yeah.
Okay, so you're going to click in there. Are you in a blank square?
Uh-huh.
Okay, so you're going to click in there and then type the equal sign. And then we're working on finding the mean. So you're going to type in the word average, all caps. And this tells you, what this is telling the program is that x, or that square, is going to equal the average of whatever values you give it. So now you're going to start parentheses.
Okay.
And so you can designate specific squares doing this. So the first square is going to be B2. Use a capital B doing this. Always type in capital letters if you're doing this for programming.
Okay.
And you want it to select all of the values from B2 to the very end. So you're going to use a colon, and then B86, and then end parentheses and hit enter.
4.771.
Yep.
Cool.
And you can do that if you start, for standard deviation, if you go to a different square. Our next question is about the standard deviation. Do the same thing. Type in equal, but this one, it has a different, it's shorthanded for Excel. So what you type in will be a little bit different. I used what I typed in was st or equals stdev period s. The s just designates that the sample is going to all be used regardless of the truth value of it.
Okay.
The truth value is something irrelevant to this right now, but it just makes it easiest to use the S. And then you can do the same thing with the parentheses, where you can select all of those squares, and then hit enter again, and it'll give you the truth or the standard deviation.
1.911.
Rounded, it should be 1.912. Because that 9 on the end would round up to 2.
2. Yeah. Okay.
So yeah. And then we have to create a histogram representing the amount spent in the Crossroad purchases.
We can't do a histogram in Excel, do we?
Well, not exactly, but you can make tables. So I'm trying to figure out really quick, or charts even. And some charts are basically histograms. So I'm going to see if I can figure out. Chart. Oh, no. Actually, I want to try something really quick. Organize. So what are they wanting us to create a histogram of is my question.
Is it of those information? That's a lot of.
Well, I mean, because there are a couple of different ways we could go about making it a histogram. I mean, if we had dates, we could do it by, like, okay, so many purchases were made on this day, so on and so forth. Right off the top of my head, though, it's almost like they just want us to make sure that we can turn it into a histogram, which is basically the same thing as making a bar chart on Excel.
Yeah. Emails.
Well, that's cool. So, here, really quick, let me do that screen share thing, if I can. Okay, so do you guys see my screen right now?
One second.
Yes.
Yeah, I see.
Okay, so let me show you guys what I did. The first thing I did was I highlighted, starting in A2, I did shift to the right to highlight, and then I just held it down until I highlighted all of the information. And then at the top of Excel, if you go into data, there's this cool little button that says sort, and just next to it a smaller one that has an A to Z and then a down arrow. And so what that did was sort it based on the method in an alphabetical order. So all of my cash purchases are followed by all of my credit, which are followed by all of my iCard. It just gives it kind of a nice layout. And then after I'd done that, so like I know looking at my histogram, based off the data that I have here, that if I look at my 20th piece of data, I come down to my chart, go to 20, wherever it is, right here. Look at that. This 1.31 is a cash purchase. Okay, that's a 21, but you get the idea. Then the next thing, highlight B2, and again repeat shift down until you have all of the information highlighted, because there are 85 bits of information here. And then go to insert, and then just click on an insert column chart. And I just did that very first one, nice and simple. And then I was able to change it a little bit more afterwards to where I have the values for, I think, every single purchase on here.
Okay.
And all of the darker ones, so you see how some of the lines are darker than others?
Yeah.
The darker ones are the ones that were given a value underneath all of the odd numbers. I don't know why all of the odd numbers were given a value and the evens ones weren't, but that's how it worked out.
Okay.
So does that make sense to you? Because this is, as best as I can tell, the histogram that they would want us to create, or close to it. And it's got some of the best free-flowing information, unless that information was already logged chronologically.
All right. So you want to run that process with us one more time, just so I can make it on my own Excel.
Sure thing. Do you want me to start from the beginning? What I did?
Yeah. So I'll go through as far as I can, and then see if you can't correct me after that. So I start highlighting the type of payment along with the numbers all in one. They're in two columns. And then I go to insert, right?
You go to data.
Here's the data.
So you have A2 highlighted, and then column A and column B starting in row 2 all the way down, right?
Yeah, down 86.
Okay. And then so in data, what you want to do, there's a little button that says, or there's like a little sort. It's almost directly beneath the data tab. And there's a smaller button that says A to Z down.
Okay. Cool.
You want to go ahead and click that one first.
All right, so just separated it into cash, credit, and iCard, and in alphabetical order.
Right. And then the next thing you want to do is highlight your entire B column, starting in B2, all the way down to B86.
Okay.
And then from there, you would hit Insert and select whatever type of chart you want to. I used a vertical column chart, just 2D, really simple thing.
Okay. And it says there's a little box that says create sparkle lines. says choose the data you want, and my data range is B2 to B86, and then it says choose where you want the spark lines to be located. And it says location. Oh, excuse me. Then it says location range. What do I type in there?
I don't think I saw anything about that.
Interesting.
That's because once you create it, you hit like insert, create chart. It should be pretty straightforward, no questions asked after that.
So you just typed in, I clicked on spark lines, that's my problem. It was let's see, 2D column. Now you just clicked on your column, and then you clicked on 2D column or 3D column?
2D column.
Okay, that's what I got. Yeah, it's similar to it. Sweet.
Awesome. Do any of you guys want to tackle, I guess, the next set? The next set is over 12 through 15.
Let me look at this. I gotta get back there real quick.
No problem.
I'll read it.
Okay.
Okay, Jessica, Mir, and a research team measured the body temperature of the sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiated dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals named Bodil, Roberta, Larry, and Purr. The seal's body temperature at the start of the dive was calculated to be. Then there's all that. We have to complete the following table to answer questions 12 through 15. So what is the value of number that goes in the position marked with an A in the table above?
Do you have an answer for it?
Do I have an answer for it?
Yes.
No, I have not. I haven't done any of these yet.
Okay.
Let's see, it doesn't tell us how much they decrease by or anything. Or even what the mean is. Or do we have to calculate the mean of these 4 seals?
You have to, you have to figure out the mean.
So, if we just come in and go...
I got 38.075 for the mean.
That's what I got.
Okay, 38.075.
Yeah, 38.75.
And then, so 38.075, and then we're looking for the deviation from the mean, x bar being the mean. So we would subtract 37.91 from 38.9, or 38.075.
Mm-hmm.
So, negative 0.165.
Yep.
Yep.
And then repeat that process, except for we're going to square the answer that we get afterwards.
Okay. So yeah, this is rounding into 3 decimal places. I'm getting 0.681.
Yeah.
Okay. And then the quantity of the quantity is equal to the sum of the numbers. And what quantity is equal to the sum of the numbers in the squared deviations column? The options are the mean, the standard variation, the variance, or none of these are correct.
I'm pretty sure that none of these are correct because the deviation of the mean, that would be the variance, I think. Like, I know in my other math class, like we used that column to find the error, and this deviation squared was the error squared, and so I'm pretty sure our deviation is just the variance, and so if it's like it should be the variance squared.
So none of these is correct?
Yeah.
Okay, makes sense to me.
Okay.
We're almost halfway there.
Yay.
Okay,
The
what is
last part's gonna go pretty fast too, so.
Right. What is the standard deviation of these temperatures? Round your answer to 3 decimals.
Do we need to know how to do it by hand? Because I think
I don't think so. But I know we can use like SPSS or Excel for our quiz.
Mm-hmm. Okay.
I got 0.715.
Okay.
Oh, and so really quick, to calculate this by hand, wouldn't we just find the distance between, like, let's call it A, B, C, D, just for the sake of these. And so wouldn't we just find, like, the distance between A and B, and then C and D, and then find the distance between those two numbers?
I'm thinking it's the sum of all the standard deviations squared, and then you divide it by the number of all the sum, or like how many numbers there are.
Really?
I'm pretty sure.
Because I don't think we've gone over that.
Right. That's what I remember it being in like other classes, but for some reason that doesn't look like. What was the answer that you got right here?
I'm sorry?
What was the answer that you got?
0.715. And I plugged all of it into Excel to get that answer.
Yeah, I trust that. I don't know if I would get that. I'm actually pretty sure I wouldn't get that if maybe I would. Interesting.
Yeah.
You said you got 0.751 or 15?
1.5.
15.
Yep. And then under certain conditions, the standard deviation can be negative. Isn't that? I always thought that's false.
Yep.
Okay, so then our answer for 12, I need to make into a positive number. Okay.
Good call. Well, no, I mean, number 12 is not the standard deviation. That's just the deviation from the mean. So, like, well, that's actually, no, I'm pretty sure that the deviation from the mean can be a negative number, but I don't think the standard deviation can.
Oh, yeah, it never can because it's squared.
Yeah.
Okay. That makes sense then.
So, yeah, just regular deviation can, standard deviation cannot be.
Okay. Perfect.
Cool. Okay.
Okay, can I read these couple questions here? Because I actually have I'm the one with all the questions. Like, I'm the one who needs the help on this one, so
Sure thing.
at least. Okay, so the number of hours students spend studying in a 40 exam were recorded. The data are represented by the box plot below.
Wait, which ones are you looking at?
I'm looking at the explanation for number 19.
Oh,
Okay,
we haven't done
'cause we
17.
still have 17 and 18 to do.
Oh yeah, sorry, I did those ahead. Okay.
It's all good.
Mhm.
So I can go ahead and read it for these two, so that then Joe, you can read for 19. So in the same study, the researchers placed thermistors, temperature sensors, in 3 seals named Chick, Starburst, and Patty, near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Sammy, Nut, Jonesy, and Butler, in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals, Bodil, Robert, Roberta, Larry, and Pear, I don't know, and their hepatic sinus. The results from the study are summarized in the table below. Okay, and then which location resulted in the most consistent temperature measurements from one seal to another? For that, you're going to be looking for the lowest standard deviation, which would be the extradural.
Mm-hmm.
Yes.
And then, can you guys define standard deviation in your own words?
I put that I did.
Okay.
Yeah.
You feel confident about that? Then 18 is true all the way around. All right, go for it, Joe.
Okay, number 19, the explanation. The number of hours students spend studying for an exam were reported. The data is represented by the box plot below. Use this box plot to answer questions 19 and 20. What is the third quartile, or Q3? Is it 6? Is that, no, is it 8?
So the third quartile would be the range of 6 to 8. But I think the number that they're looking for would be 8 itself.
Okay. Yeah, okay. That makes sense. So the second quartile is the left half of the box. The third quartile is the right half of the box. Is that right?
Yeah.
Okay. And then the first quartile is from like 2 to the beginning of the box, and the fourth quartile is from 8 to from the end of the box to the end of the line, essentially.
Right.
Okay.
Okay. So what percentage of the day lies between 4 hours and 8 hours? Don't include a percentage sign. Based off what we just said, it's going to be 50% of the data. Because if the quartiles are all divided evenly, as far as that's where 25% of the data lays, 25% will lie between 4 to 6, 25% will lie from 6 to 8. So between 4 and 8, there's going to be 50%.
Okay. Sounds like a deal.
Okay.
All right, so let's read 21, 22.
Do you want to, Naomi?
Yeah. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm the city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume 1.59 parts per million is a value of that, and that is equal to 2.52. It is reasonable to assume the measured nitrate concentration is normally distributed. Use information. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Oops. Like the mean of the measured.
Okay, so do you know what those two symbols are?
Yeah, the mean and the standard deviation.
Okay, okay, perfect. So let's see. Standard deviation. So we got mean. So 2.52 minus 1.59. Huh?
Well, okay, so one thing, the mean is going to lie directly between those two numbers.
Yep.
So I don't know how you were.
Well,
Are we just going to calculate the distance between them?
yeah, I was going to take the distance between them and divide it by 4, because what you've got here is you've got u plus 2 standard deviations is equal to 2.52, and then u minus 2 standard deviations is 1.59. So those right there, the difference between those two numbers is 4 standard deviations.
Okay.
Does that make sense?
Yeah.
Okay, so you're just going to take the difference between each of them, and the first part we're looking for is, let's see, we're looking for the average. I was doing number 22. Sorry. Oh yeah. Sorry. Go ahead. You were right. I was doing number 22.
Well, you're on the right track there. If you go ahead and do that, but instead of dividing it by 4, divide it by 2, because you're looking to split the distance perfectly in half. And then take whatever number you get there and subtract it from
2.52.
Yeah. So we go 2.
Okay.
Wait, so how do you set it up? It's 1.59 minus 2? Or
So the 2.52 minus 1.59.
Oh.
So I got that our mean is going to be... That number's way too high, dang it.
I got my mean as 2.055.
Right, okay.
And I got my the standard deviation I got in rounding into 3 decimal places was 0.233.
0.233?
Yes.
What'd you get for the mean?
For the mean, we got 2.055.
Oh.
Okay, that holds up. So 0.53 for the standard deviation?
What was that?
What did you get for the standard deviation again, Joe?
0.233, but I'm thinking that might be wrong.
No, I just tried it, and if you take that and you multiply it by 2 and then you add it to our mean, it goes to 2.521. So you round that 1 off and you get 2.52.
Okay, perfect.
So yeah, it stands up. Between what two measured nitrate concentrations do approximately 68% of the data values lie? Well, we have our standard deviation and our mean. We can safely say so we go 2.055 plus 1 standard deviation. The answer is going to be D. Because the top end is going to be 0.2 or 2.288, and there's only one answer with that option.
I actually got it's 1 second. It's between 1.822 and 2.288, right?
Yeah.
So that's actually D for me, like dog. Is that what you said?
So
Yeah, I said D.
Oh, I thought you said B,
Oh.
like boy.
I was supposed to be
I was
also.
like, oh, they're in different order. That's crazy.
Sometimes that happens. Be careful, because it's happened before.
Yeah, it has. I haven't noticed it, but I wouldn't doubt it. So
So what is the value of the mean of the standard normal distribution?
mean of standards of value. Mean of
Is this the one that the mean just carries down and is the same thing?
So I'm wondering.
I feel like it is. Because I know we got stuck on
Yeah,
a question similar to this one for a really long time last time we met.
Yeah.
But what would we base it off of? What's it? Because it's.
It's in lesson 5, I think.
Yeah.
We talked about that.
Yeah.
Because the sampling that we're dealing with right now, if I remember, it's like
Okay,
just
here it is.
means.
When the mean of a normal distribution is 0 and its standard deviation is 1, we call it the standard normal distribution.
So wait, what?
Okay. When the mean of a normal distribution is 0 and its standard deviation is 1, we call it the standard normal distribution.
So the mean is going to be 0 and the standard deviation is going to be 1 for 25.
Yep.
Naomi, you're fantastic.
Well, you said standard distribution. No.
Okay, so 25 is 1 and 24 is 0?
Yes.
4 is 0, 25 is 1.
Yep. We got this.
Mean of a standard normal distribution is 0. The value of the standard deviation is... Okay, that makes sense.
Yeah. It's good to know.
Actually,
The admissions committee for most Masters of Business Administration MBA programs require the Graduate Management Admission Test, GMAT, as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. Sources there. The minimum GMAT score required for admission to the MACC program, holy cow, in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Bummer. Use this information to answer questions 26 through 31. What is the probability that a randomly selected student will score above a 542.3 on the GMAT? We need our applet.
Wait a second. No. It's 0.5 because that's the mean.
What?
We don't need an applet for that one.
So it is. Joe, you're a genius.
Wait, what is it?
Hey.
542.3 is the mean, so it's in the exact center anyways. So the answer would just be 50%.
Oh.
Or 0.5. Hence the reason it says round to the nearest 10.
Oh, wow. Smart. Smart.
Okay, next one we need the applet for, though.
So I'm going to do the math on this one real quick. 600 minus 542.3 divided by 0.54.
So what are you using to divide by in this one, Joe?
The standard deviation is 120.54.
Well, is that
So
all
I'm just
you
using the standard. I'm just using the standard deviation.
Okay.
I'll have to pop out an applet here real quick.
0.479.
And it's above, right? Below. Below.
Or below. Yeah.
Zero point three one six.
Blue.
I got 0.684 on the probability applet.
Oh, did you highlight the middle part too?
Yes. Because the z-score was a positive number, it was positive 0.479.
Mm-hmm.
So you're going to use that right-hand bar, and everything underneath it is what we're looking at.
Okay. All right, then I got the same thing too.
You got, Joe?
Yeah, well, your probability was 0.6839.
Because of how I rounded, I got 684.
Okay, perfect. Yeah, it says 6. Yeah, 3 decimal places, 0.684. Good call.
Okay. So then, what is the probability that a randomly selected student will score above a 600 or above? So just reverse it. 0.316.
0.316. I got 0.317 when I used it, when I put it into my applet and I rounded it up.
Really? What? How did?
Yeah.
Yeah, I got the same thing as you did, Dylan.
I'm using a different applet, probably than you guys are using. I'm just using one that I found off the internet.
I'm using the one in our reading.
I'm not using that. I should probably use that one.
I guess one thing to say about it, it would have to end in a 6, because the two probabilities, because it's asking for above and below, would have to add up to be 1, even. And if you ended with 7, it wouldn't add up to be 1. It would actually add up to be greater than 1.
Yeah, this is where you get into like rounding errors. So
Right.
It would just, I guess, more than anything, it would just be 1 minus the previous answer, which is 0.316. So, okay, find the GMAT score that corresponds to the 10th percentile. So, Z score is 10%. Okay, so 10%. I'm having trouble doing that on this applet because I can't just type in 0.1.
No worries. So yeah, on this applet, so the z-score that corresponds with that, are we just looking for the z-score? No, we're looking for the GMAT score. Okay, the z-score that corresponds with 0.1 is 1.282.
So the z-score is equal to 1.282 is equal to your x minus 540. What was that number? Minus 542.3 over 120.54. 1.282 times 120.54 plus 542.3. Now, what was the question again?
So we're looking for the GMAT score that corresponds with somebody scoring in the 10th percentile.
So it's a negative z-score is actually what we got.
No, because wouldn't in the 10th percentile be like the top 10% of people?
That would be the bottom 10% of people.
Bummer. I always get my things mixed up. Well, I got the answer for 30 then.
Oh, good. Good call. I was on my way of getting that one actually. So
We just use the negative z-score. That doesn't really change too much as far as how the equation works.
no, it's pretty much the same. Okay, so I'm gonna do that. Yeah, 120.51.
So I got 387.698 for this one.
All right, so our z-score is negative 1.282, correct?
Yes. Oh, we're rounding to the nearest.
Multiplying it. Okay, so we're going to have 120.54, because that's our standard deviation,
Mm-hmm.
and multiply it by negative 1.282.
And
We're
these
gonna
ones
get
are rounded
negative
to the nearest
100.
whole number.
What was that?
These answers, instead of rounding to the the nearest third decimal or whatever, it's to the whole number.
Oh, okay. So you got 388, is that what you got?
Yeah,
Number 20.
on 29.
3.
And then I got 697 on 30.
Okay.
Okay.
All right, sounds good. So number 30 was, let's see, it was 6. What'd you say?
Huh?
Number 30 was 600 and what?
97 is what I got.
Okay, sounds good. So the first quartile of the distribution of GMAT scores, that's our 25%. So what is our z-score when we go 25%?
So looking at the first quartile, the weird part is this probability app that only divides it into thirds. But I guess that's still going to be right. The z-score for the first quartile is negative 0.674.
674 is equal to. Is equal to x minus 542.3 over 120.54.
Joe, do you start this all over when you write it out each time?
I do.
Nice.
I do it all again. I'm kind of a bum like that.
I think it's an important thing. As far as math goes, if you do it by hand, you can do it with a calculator.
Yeah.
And 32, is that the same thing as 31, basically?
Yeah, but instead of using the negative z-score, you'll use the positive.
Okay.
So I got for number 20 or number 31. I got 461.
I got 534.
For the 25th percentile.
Yeah.
It can't be almost as high as the mean, can it?
That's what I'm thinking. Well, let me run mine again really quick.
Maybe I'll run mine again one more time. I'm getting 461 again.
Okay, I got 461 that time. I don't know what changed necessarily, but what I got.
Okay, so it's now the 25th percentile. It's going to be the positive z-score of that, right?
Yeah.
I got 624. I gotta take a call real quick. This is kind of important.
Okay. I got that too.
Dude, I'm doing great. What are you doing? Yeah, good to hear. Hey, I'm in a video conference real quick. I just have one question for you. Did you get my, did you get the email I sent you? I tried to send it to your phone. Okay, sweet deal, sweet deal. Yeah, I was just, I'm gonna finish the video conference. I got like 3 questions left, and then I'll give you a call back. Is that all right? Okay, 1, 2, bye.
What did you guys get?
For what number?
32.
I got 624.
Mine doesn't round up, it rounds down to 623.
Really? Because I'm getting, let's see. Are you doing anything with your rounding? Because I'm going super long with my rounding.
1 second, let me... See, and I'm doing it really short. I'm just going directly to the right of my the first decimal, or looking at just the first decimal, and rounding that down. So let me 1 second finish this by hand. So if I go super long with my rounding, yeah, I get 624 then. But if I stay super short, I would just get 623.
My total result after not doing any rounding is 623.5. And I'm pretty sure, I don't know, I think the applet, like, are you just typing stuff in, like,
so mine, after doing the whole thing without doing any rounding, is 623.47396. So the 6 rounds up, 9 rounds up, 4 would round down, 7 rounds up, that 4 becomes a 5, which would round up. But if I look at this as 623.4, that 4 would round down.
Because I'm just getting 623.54396.
Did I do something wrong here?
Hmm.
1 second, let me look at this really quick. You got .54396?
I sure did.
Hmm.
You want me to show you on my calculator? It's on my spiffy phone. It's a piece of junk. I'm just joking. I'm not going to show you my phone. But
Because
um,
I was gonna say, from what I did by hand, let me run it again on my calculator on my computer really quick.
okay, do it and don't do any clearing. Just take it and like get your last
Yeah, that's what I do.
multiply it by your next number and then whatever you use. Okay, so our z-score again is 0.674, right?
Yes.
Okay. 0.674 times 120.54. That gives me 81.24396.
Yep.
Is that what you got? Okay.
Yeah.
Now I'm going to add 524 or 542.3.
See, yeah, and I did that by hand and then on a calculator. I got the same answer both times.
Okay, so 81.2 plus 542.3. That decimal is going to be a 0.5.
Wait, what was your? So you had 80 what point?
81.24396.
Okay.
Yes, 81.23 or 24396.
Okay, now I'm going to add 542.3.
Oh, I'm adding the wrong mean. That's what it is.
Okay,
623.54396.
all right, just making sure we're all coming into common grounds here.
Okay. Yeah. Okay, I got the same thing now.
Okay, cool.
Woo!
I don't know how, but my mean somehow ended up as 542.23. I think I wrote the 2 twice.
Okay.
Okay. 3 questions left. We're almost there.
Okay, consider a simple random sample of n is equal to 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples?
That's the same mean.
Who's the nearest?
Huh?
So that mean is the one that stays the same. It would stay 542.3.
Okay.
Wait, I don't think. Wait, isn't that just? It says use 26 through 31.
Right. Well,
Do you still use it?
Yeah, because it's still asking us about the GMAT. And then this standard deviation is the one that's our standard deviation divided by the square root of n.
Okay.
So 34 it's just the standard deviation. What is the standard deviation? Okay, yeah. So it's 120 point whatever.
0.54 divided by the square root of 15.
Yeah, gotcha.
Deviation of what again? Sorry. Of. Wait, it's a standard deviation of what for 34? 120.54.
Yes.
Yeah.
So it's
I'm getting
10.98. Mm.
Okay, I'm getting 31. It's to 3 decimal places. 31.123 is my answer.
Yep, that's what I got too. Beautiful.
That's awesome.
31 point, wait, 30 point what? 31 point,
123. You understand that one?
no.
Okay. So what they're asking for is, like, if you take the standard deviation of like an entire population, or like you say you do a study, you have I don't know how many people, like everybody in the entire school, and all our standard deviation, it says here, is 120.54.
Yeah.
All right. Okay. So say they took 15 random students out of that original population. All right.
Mm-hmm.
And they said, now find the new standard deviation, the expected standard deviation of these 15 students. What you do is you take the original standard deviation and divide it by the number of the students that you just barely just selected. So it would be 120.54 divided by the square root of 15.
Oh, yeah, okay.
Okay, so that's the new standard deviation of that new sample that you just took of the original population.
Okay, cool. Okay, thank you.
Mm-hmm.
So then, for 35, we would do basically what we did up above with the 600 minus our mean, but then we're going to use our standard deviation from 34 when we divide it.
Yeah. So I'm getting my z-score is equal to 1.8539. That's my z-score. And so we're doing everything below that. Is that correct?
No, everything greater.
Greater.
We're doing greater than 600.
Oh, okay. Greater above 1.8539.
Are you with us, Naomi?
Yeah, I am.
Okay, good deal.
So my answer is 0.032.
Yep, that's what I got.
Cool.
Hell. Woo.
Alright, so let's hit submit on this. Did we miss anything? Nope. And boom diada. Looks like we missed one.
Dang it.
Bummer.
Oh, snap.
Hey, that's not bad though.
Yeah, it's
We missed
not.
1 out of 35. And it was over something that I don't think we 100% covered.
Yeah, it's a good thing to see, though.
Yeah. So, really quick, I want to discuss that really quick. I think that they're qualifying 100 as a parameter because their 20 sample students are taken from within that 100.
Yeah.
And that's the only way I can think of it.
Yeah, that makes sense. I'd go with that.
Okay. I'll look up parameters a little bit more, and if I find out anything else, I'll let you guys know.
Okay. We don't really talk about parameter or anything, right?
I don't think we have, honestly.
Yeah. Shoot. Well, yeah. You guys are very helpful.
Cool.
Alright.
I'm going to stop this broadcast, and I'll post it to our board when it uploads to YouTube, okay?
All right.
Alrighty,
Thank
thanks,
you.
guys.
Have a good night, guys.
Yeah,
Okay.
appreciate it. Yeah.
Good luck
You
on
too.
the
Good luck on the test.
Alright, yeah, you guys too. Good luck.